Alright guys, for number 7, you should have got no vertical asymptotes because the bottom of your equation can never equal 0. You got a horizontal asymptote at y equals 1. You got a y-intercept at 0, 0, and x-intercept at 0, 0. Your first derivative is 6x over x squared plus 3, quantity squared. Your second derivative is, well, I don't know where our second derivative. How about negative 18x to the fourth minus 36x squared plus 54 all over x squared plus 3 quantity to the fourth. You have a point of inflection at x equals 1, x equals negative 1. You have a critical number at x equals 0. You're decreasing from negative infinity to infinity, increasing from 0 to infinity, concave down from negative infinity to negative 1, concave up from negative 1 to 1, concave down from 1 to infinity, and there is your graph. A lot of information there. Alright, number 11, we got a vertical asymptote at x equals 1 and x equals negative 1. Horizontal asymptote at 0, y equals 0, y-intercept at 0, 0, x-intercept at 0, 0. You might say, why is there a horizontal if we have an ordered pair at 0 for y? But maybe that's, remember horizontal asymptotes are at the ends. Maybe something else is going on in the middle. Our first derivative is negative 2x squared minus 2 over x squared minus 1, quantity squared. Our second derivative is 4x to the fifth plus 8x cubed minus 12x over x squared minus 1, quantity to the fourth. There are no critical numbers. Your point of inflection is 0, 0. You're decreasing from negative infinity to negative 1, decreasing from negative 1 to 1, decreasing from 1 to infinity. So everywhere is decreasing. You're concave down from negative infinity to negative 1, concave up from the next interval of negative 1 to, yep, you're concave down next, and then you're concave up. And there's your graph. Alright, number 15, you have a vertical asymptote at x equals 0. A horizontal, there is none because you get infinity and negative infinity. There is a slant asymptote by doing long division at y equals x. There is no x or y intercept. Your first derivative is x squared minus 1 over x squared. Your second derivative is 2x over x to the fourth or 2 over x cubed. Your critical number is 1 and negative 1. Points of inflection, there are none. My ordered pair for my critical number of 1 is at 2, and at negative 1, where it looks like we're at negative 2. Alright, we're increasing from negative infinity to negative 1, negative 1 to 0, decreasing, decreasing from 0 to 1, and increasing from 1 to infinity. And that's what your graph looks like. For number 16, you have a vertical asymptote at x equals 2, x equals negative 2. There is no horizontal. There's a slant at y equals x. Y-intercept and x-intercept are 0, 0. You have a first derivative of x to the fourth minus 12x squared over x squared minus 4, quantity squared. For your second derivative, 8x to the fifth plus 64x cubed minus 384x all over x squared minus 4 to the fourth. Your critical numbers are 0, 0, 3.46 and 5.196, negative 3.46 and negative 5.196. You have points of inflection at x equals 0, and then it looks like I have x equals 2 and x equals negative 2, but I have those crossed out for some reason. Then we have increasing from negative infinity to negative 3.46, decreasing, 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 increasing. Why do I have so many critical numbers there? Well, you also have to worry about when your derivative is undefined. So that's why I have more than just the 5 intervals. Alright, concave down from negative infinity to negative 2, up from negative 2 to 0, down from 0 to 2, up from 2 to 0, or 2 to infinity, excuse me. And then there's your graph. And Alright, 17, we have a vertical asymptote at x equals 4. We don't have a horizontal. Your slant is at y equals x minus 2. We have a y-intercept of 0, negative 3, no x-intercept. Your first derivative is x squared minus 8x plus 12 over x minus 4 squared. Your second derivative is 8x minus 32 over x minus 4 squared. You have critical numbers at 6 and 2 and -2. There are no points of inflection. I said x equals 4, but it doesn't change from concave up to concave down, so it doesn't count. Increasing from -infinity to 2, decreasing from 2 to infinity, decreasing from 4 to 6, increasing from 6 to infinity. And concave down for the first interval, concave up for the second, and there's your graph. Number 18, we got a vertical asymptote at x equals 2, a horizontal none, slant y equals 2x minus 1, y-intercept 0, -2.5, x-intercept none. First derivative, 2x squared minus 8x plus 5 over x minus 2 quantity squared. Second derivative looks like I got -4x cubed plus 16x squared minus 4x minus 12 over x minus 2 to the fourth. Points of inflection, none. Critical numbers, 3.22 and 7.9, 0.77 and -1.9. You're increasing on that first interval, decreasing, then increasing, and there's your graph. Alright, there are no asymptotes on 29. Your y-intercept is 0, 1. Your x-intercept, I don't have any, it doesn't look like. But there should be one, I don't know why that's blank. We got a first derivative of 9x squared minus 9. Critical numbers are 1, -5, -1, 7. Second derivative is 18x. Point of inflection is 0, 1, and there's your graph. To get that x-intercept, I should have done the quadratic formula. Alright, the next part of the chapter is optimization problems. What it is doing is applying derivatives to real-world problems. So here is the steps for solving these things. We are going to state what is given. So usually they'll give you the side length or maybe a derivative or something like that. What do we want to maximize or minimize? They're going to ask you that. They're going to say, please maximize your volume. Please maximize your area. Whatever you're maximizing or minimizing, that's what you're finding the derivative of. For 3, you're going to solve the given equation for one variable. Step 4, you're going to substitute the equation from number 3 into the maximum or minimum equation. 5, you're going to find the derivative, and then you're going to set the derivative equal to 0 and solve. So if you save all that information, write all that down, we can do these steps as we go. Alright, here's example 1.